Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Diana Ayu Latifah. I'm from International Program on Science Education 2017. And in this video, I would like to explain a little more about general properties of wave through a presentation or PowerPoint. So let's check my PowerPoint with my little explanations. So hello everyone, welcome to my presentation with the topic is general properties of wave. There are core competence and basic competence. For the core competence, for the general properties of waves is to understanding and applying a knowledge which are factual, conceptual, and procedural knowledge based on the curiosity of science knowledge, technology, art, culture related to the real phenomenon. And then for the basic competence for its topic or for this topic is 3.11 is analyze the concept of vibrations, wave, and sound in daily life, including human hearing system and sonar system in animal. For the 4.11 is the served result of the observations about the vibrations, wave, and sounds. But actually, before we are going into the next presentation, I provide the video. I took this video from YouTube with the topic is wave. But here I also provide and I will include the video after this.
Ever seen a Mexican wave at a sporting event? The effect is a pretty cool display that goes all around the stadium, but no one has had to move seats. All waves can transfer energy from one place to another without transferring any matter. This is done by a series of disturbances or vibrations that carry the energy. Just like the people in their seats only moving up and down when it's their turn. Waves can transfer energy through solids, liquids, gases and empty spaces, otherwise known as vacuums. There are two types of waves, which we look at in more detail in another video, but the basic features are the same. These four words describe different properties of waves. Let's discover what each one means. The frequency of a wave is the number of complete waves passing a fixed point in a given amount of time. This time period is usually 1 second. This is what one complete wave looks like. So if this was our time period, the frequency would be 5. Frequency is given the symbol F and is measured in units called hertz. Hertz measure how many complete cycles per second. So how many people in our Mexican wave stand up every second. The frequency and period are often confused. The frequency refers to how often something happens, whereas the period refers to the time it takes to happen. The period of a wave is the time for one complete cycle, so the time taken for one person to stand up, wave, and sit down. This would be measured in seconds. When something happens repeatedly, we say that the event is periodic and refer to the time for the event to repeat itself. The period of the Earth to orbit the Sun is 365 days. The period of a day is 24 hours. The period of a typical class at school is 45 minutes. Now for wavelength. The wavelength is the distance between a point on one wave and the same point on the next wave. For example, two peaks or two troughs. Wavelength is given the symbol lambda from the Greek letter and is usually measured in meters. Wavelength can vary hugely in size. X-rays are very short, visible light is here, and FM radio waves are much longer. So we've looked at the frequency, period and wavelength so far. Let's finish with amplitude. As waves travel, they create disturbance. The amplitude of a wave is the distance from the maximum disturbance to the undisturbed position. Think of a very flat sea, and then an incoming wave. The amplitude is the height of the top of the wave from the flat sea. Can you add the labels to these waves and work out the frequency? Notice that the top one is distance and the bottom one is time. Pause the video, work it out and click play when you're ready. Did you get them right? In another video, we'll be looking at wave speed equation and connecting wavelengths and frequencies. For now, you just need to know what these 4 key words mean.
If you liked the video, give it a thumbs up and don't forget to subscribe. Comment below if you have any questions. Why not check out our FuseSchool app as well? Until next time.
So guys, that's all for the video. Next, it's my turn to present the general properties from my PowerPoint or my presentations. First, after we are know what is wave, why do we have to learn about wave? Actually, after we are know what is wave from the video, I would like to ask, why do we have to learn about wave? But actually, it is also providing the reason why we have to learn about wave, right? So, it is simply because this topic is provide a rich glimpse into the physical world that we seek to understand and describe as students of physics. Actually, there are another reason why we have to learn about wave or this topic in this time. It is because it will relate to another example, which is sounds, light, and etc. So, why we have to learn about this topic or the general properties? It is because we are going to learn after this about the sounds, light, and etc. Or the example, or the other example of work in real life. Here, what is wave based on my PowerPoint? Wave here is a disturbance in a medium that propagates through the medium of its own volitions. The disturbance here is a line by me. Disturbance means it's the interruptions of settled in peaceful conditions. So uh, when we have a matter it is could be solid, gas, or liquid, and the matter it is stay in its own positions, and there is a disturbance or disturb come. It is called the disturbance, or it will produce a wave. Next is the example of wave. There are some example of wave. First, there is a standing wave. Standing wave here is combinations of two waves moving in opposite directions, each having the same amplitude and frequency. I will try to draw the example of standing waves here. So, standing waves, it is will like this. There is this is the actually wave coming wave, and this is the coming wave from actually this is my left through to the right, what is the right standing, and it will producing the what is the coming wave, and then the other opposite coming wave. It is called the standing wave. Like this. It will. Nah. Sorry for bad drawing. It's actually I would like to give you an example. Okay, next the mechanical waves. Mechanical waves here are produced by a disturbance, such as a vibrating object in material medium, and are transmitted by the particles of the medium, vibrating to and fro. Such waves can be seen or felt in and include waves on a rope or spring, water waves, and sound waves in air or in other materials. Next is the other example of waves is electromagnetic wave. Electromagnetic wave here is a progressive or traveling wave, is a disturbance which carries energy from one place to another without transferring matter. There are two kinds of electromagnetic wave. First is transfer wave. Transfer wave is a moving wave whose oscillations are perpendicular to the directions of the wave. A simple example is given by the waves that can be created on a horizontal length of string by anchoring one end and moving the other end up and down. So what is oscillations? Oscillations means repetitive or the same type of time. This is the repetitive variations in the same time of time. And here is the example of the transverse wave. Transverse wave, it has crest and it has trough. The next is the other example of electromagnetic wave is longitudinal wave. Longitudinal wave is a wave in which the directions of displacement is the same as the directions of propagation. For the longitudinal wave, we could see that the wave here has the compressions and rarefactions. So that's all for the example of wave. The next is basic type of wave. The basic type of wave here, there is a pulse. A pulse is a single disturbance and only assaults the medium once, and it's characterized by amplitude. And here is also the pulse, the example of the pulse. Actually, how the pulse occur, it could be explained or described when we have a drum and we have a stick and we try to hit the drum once with the stick. It will produce the pulse. The next is the periodic. Periodic wave is many identical pulses that is repeatedly assaults the medium and resulting a wave. So actually, periodic waves means a pulse that happen in several times. So it could also, I will give an example like when we hit the drum is more than once. Actually, after we are learn what is the basic type and then the example of the wave, we are going to the main of this topic is the properties of wave. First properties of wave here, there is an amplitude. The amplitude is a maximum displacement from the equilibrium of the disturbed medium. So here is the equilibrium of the disturbed medium, and here is the height maximum displacement of the disturbed medium in equilibrium. Amplitude describes the severity of disturbance associated with a wave. The bigger its amplitude, the more severe the wave is. Okay, that's all for the amplitude. We are going to the next properties, which is frequency. Here, the frequency is a number of waves passing a point in a certain amount of time. So the frequency means one wave, one wave in happen through one period of time, or one waves happen in several or the amount of time. And then the other properties is period. Period is the same. It is the time it takes to complete one cycle or an amount of time it takes for one wave to assault the medium. Period, it also has the formula is 1 over f. The next properties of wave, there is a wavelength. Wavelength is a physical size of one whole assault. The distance between two consecutive peaks or true is represented by the Greek letter or lambda. So actually, wavelength it is has one crest and one actually happen from the crest to the other crest. So here is the crest to the other crest, right? But actually the crest here is have 1/2 of crest, and it is also have 1/2 or half crest. So it could be described as wavelength is include one crest and one through. This is called as this is also called as wavelength. The next is wave speed. Wave speed is a motion depends on properties of medium, the distance of wave travel in given amount of time. So wave speed means the velocity of the wave travel in time. Here is the formula. The formula is the velocity equal to the distance over the time. The distance here is the wavelength and the time here is the period. But when the information is include the frequency, but it is not include the period, we could use this formula of the frequency to find out the velocity of wavelength is velocity equal to lambda times f, because the t and f, or the period and the frequency, has a relations of it is the proportional. Next, we are going to the exercise of this topic. For this exercise, for the first exercise or for the first questions is the graph below represents the displacement against positions of a water wave at a particular time. First, find the amplitude or dA. The second is find out the wavelength. So we already know that the amplitude is the maximum displacement of its equilibrium disturbance or the matter. So here is the maximum displacement of the equilibrium of matter. So the number of amplitude here is equal to 10, right? Because the information is there. The second is find out the wavelength. So I already explained also the wavelength is including one crest and one through. So here is the wavelength. So the number of the wavelength or the lambda is equal to 4 with the for sorry for sorry. So the lambda is equal to 4. That's all for the first questions. We are going to the next exercise. Here the second questions or the second exercise. The graph below represents the same water wave as in the first graph. Find first the amplitude, second is the time period or t, and the third is the frequency. Here's we actually know from the first questions that the amplitude is here with the number is 10. So here is the amplitude. The next is the time or the period. We have an information here is the time. The period's mean is one wave happen in several amount of time, a certain amount of time. So here is the time for one wave happens. So the t or the period is equal to 0.5, right? And second, the third is find out the frequency. So we already know that the frequency is the disproportional of the period. So f equal to 1 over t. So it is equal to 1 over 0.5, right? It could be 2 hertz. Yeah, that's all for the exercise or the example questions for me in these presentations. Next is I have a quiz, and please scan this QR code to exercise more about this topic or the general properties of wave. So everyone, that's all for my presentations or explanation about the general properties of wave. I hope this video will help you to understand more about this topic or the properties of wave. Thank you for watching. See you in the other video or the other topic. Thank you.